This is the standard circular manhole, the most common access point in any sewerage system. We provide a manhole wherever the sewer changes direction, gradient, size, or material, and at every junction of two or more sewers. Spacing is 30 meters for small sewers below 0.9 meter diameter, 75 meters for medium sewers, and up to 150 meters for trunk sewers. The key dimensions you must remember: the cast iron cover has a clear opening of 560 millimeters as per IS 1726. The access shaft is 600 millimeters in diameter. The working chamber below is 1200 millimeters in diameter, with a minimum height of 1.8 meters. Step irons are 20 millimeter diameter, spaced 300 millimeters center to center, with the first step not more than 450 millimeters below the cover. The benching slopes at 1 in 6 and the half-round channel matches the sewer pipe diameter. For maintenance, inspect the cover and frame monthly, remove silt from the channel, repair any eroded benching, and always test gases with a 4-in-1 detector before any worker enters. Remember, no man entry is permitted if the sewer diameter is below 0.9 meters. Now we look at the drop manhole. This is used wherever the difference in invert level between the incoming sewer and the outgoing sewer is more than 600 millimeters. A vertical drop pipe carries the flow down so that splashing does not erode the benching. The key dimensions: the vertical drop must be at least 600 millimeters. The drop pipe diameter equals the sewer diameter with a minimum of 150 millimeters. A rodding eye must be provided at the top of the drop pipe so a flexible rod can be inserted for clearance. And importantly, a direct open channel is also provided on the inlet side for rodding access and flow gauging in case the drop pipe blocks. For maintenance, rod the drop pipe via the rodding eye, check the benching for splashing damage, and clean the direct open channel separately as it silts faster than the drop pipe. A lamp hole is a vertical pipe, typically 150 to 300 millimeters in diameter, provided where a full manhole cannot be installed. A lamp is lowered down the lamp hole, and the next manhole is observed via mirror test to check the sewer between them. Lamp holes are largely superseded by CCTV inspection in modern works, but you must still know them for the exam. Key dimensions: lamp pipe diameter 150 to 300 millimeters, made of cast iron or stoneware. Spacing from the next manhole is 45 to 90 meters. The depth equals the sewer crown depth, capped at ground level with a locked cast iron plate. For maintenance, check the cap integrity for security and odor. Run a mirror test before and after monsoon. And remember, no worker entry through a lamp hole ever. The pipe is too narrow. A junction chamber is an enlarged manhole at the meeting of 3 or more sewers, or where a large building connection joins a small public sewer. It permits inspection, rodding, and minor flow regulation. Junction chambers are usually rectangular, unlike the circular standard manhole. Planned dimensions range from 1500 by 1500 millimeters to 3000 by 1500 millimeters, depending on the number of inlets. Inlet sewers must meet the outlet at less than 60 degrees. Wider angles cause turbulence and silting. The channel inside is shaped with smooth curves. The cover is heavy-duty cast iron or steel fiber reinforced concrete, with multiple covers if the chamber is large. For maintenance, silt accumulates faster at the inlet dead corners due to flow stagnation. Clean these frequently and inspect the curved channel for erosion. The turbulent meeting of multiple flows wears the channel faster than a straight one. The inverted siphon carries the sewer below an obstruction, a river, a road, a rail line, or a natural depression. It dips down, runs under the obstacle, and rises again. The flow inside the siphon is under pressure, not gravity. Despite the name, this is not a true siphon. There is no negative pressure. The critical design feature is multiple barrels of graded diameter. Dry weather flow alone is too small to reach the self-cleansing velocity of 0.9 meters per second in a single barrel. Barrel 1 is sized for minimum dry weather flow. Barrel 2 cuts in at average flow via an overflow weir. Barrel 3 handles peak storm flow. Inlet and outlet chambers have penstocks, so any one barrel can be isolated for cleaning. Vent pipes at both chambers release gas buildup. And here is the most asked exam point: inverted siphons must be cleaned twice a day, as per CPHEEO Manual Part B. Field's automatic flushing tank provides periodic flushing of branch sewers at the upper or dead end where flow is insufficient for self-cleansing. The tank accumulates water slowly, then discharges it suddenly via a siphon. The resulting wave scours silt out of the branch sewer downstream. Working principle: inflow fills the tank, water level rises above the inverted U siphon crown, siphonic action starts, the tank drains rapidly into the flush pipe, air re-enters when the level drops below the seal, the siphon breaks and the cycle repeats. Key dimensions: tank capacity 200 to 400 liters per CPHEO, often sized at 1 liter per meter of branch sewer length. Discharge time should be less than 2 minutes for a strong scouring wave. The flushing cycle is typically 4 to 12 hours, controlled by inflow rate. For maintenance, check siphon priming weekly. The refill control valve needs annual servicing. In a combined sewerage system that accepts road runoff, the catch basin is the curbside structure that admits stormwater from the road while trapping grit, leaves, plastic, and other large solids that would otherwise clog the sewer. The grating is cast iron with bar spacing not more than 25 millimeters so that it retains debris. The silt chamber depth is at least 300 millimeters below the trap level. This is where grit accumulates until manual cleaning. The trap water seal is at least 75 millimeters deep. This prevents sewer gases escaping into the street. The outlet to the sewer is 100 to 150 millimeters in diameter. For maintenance, clean the grit chamber before every monsoon. A choked gully equals street flooding. Replace broken gratings immediately. They are a safety hazard for pedestrians and vehicles. Check the trap water seal monthly. If dry, refill with water. A ventilating shaft is a vertical pipe 150 to 300 millimeters in diameter that releases sewer gases to atmosphere above the highest nearby building or street lamp. Ventilation prevents three things: buildup of explosive methane, pressure surges in the sewer during sudden inflow, and corrosive hydrogen sulfide accumulation that drives crown corrosion. Key dimensions: pipe diameter 150 to 300 millimeters, larger for trunk sewers. Material is cast iron or galvanized iron. The shaft must extend at least 1 meter above the highest nearby roof ridge or street light bracket. Spacing is every 100 to 150 meters of sewer. The top has a cowl with a bird guard and fly screen made of stainless steel mesh. For maintenance, inspect the cowl every 6 months as birds and insects block the screen. Monitor downstream hydrogen sulfide concentration. If above 2 parts per million, add another vent shaft or start chemical dosing. In a combined sewerage system, when storm flow exceeds the design dry weather flow times 6, the typical interceptor ratio, the regulator diverts the excess to a storm overflow that discharges to a natural water body, bypassing the treatment plant. The most common type is the leaping weir. A slot in the invert of the channel allows dry weather flow to fall through into the interceptor sewer, while the higher storm flow leaps over the slot and continues into the overflow channel to the receiving water. Other regulator types include the side weir, the float regulated gate, and the stilling pond regulator. For maintenance, check the slot dimensions and side weir crests annually as wear changes the diversion ratio. Inspect the overflow channel for debris after every monsoon end. The regulator is critical infrastructure. A malfunctioning regulator either overloads the treatment plant or sends untreated sewage to the river. The sewer outfall is the discharge point of the sewer after treatment into a receiving water body, a river, sea, or lake. The design must account for high tide or flood backflow protection, proper mixing and dispersion of the effluent, and protection against debris and aquatic life entering the sewer. The key feature is the tide gate, also called a flap valve, made of cast iron or HDPE. The flap opens outward at low tide to allow effluent to discharge and closes automatically against backflow at high tide. Other components, diffuser ports, distribute the effluent over a wider area for mixing. A screen keeps fish, weeds, and debris out of the sewer. A head wall and apron resist erosion and uplift. For sea outfalls, a marker buoy warns shipping. For maintenance, clear weed, silt, and plastic at the head wall after every storm. Test the flap valve operation monthly. They jam open or shut due to debris or corrosion. The building connection is the sewer that connects a private building drain to the public sewer at the curb. It always uses a Y or T branch with a small inspection chamber called the Chamber of Jurisdiction. This is the legal boundary of responsibility between the property owner and the public utility. Key dimensions: connection pipe diameter is 100 to 150 millimeters, made of stoneware, RCC, or HDPE. The slope is at least 1 in 60 for self-cleansing at low flow. The branch into the public sewer is always at 45 degrees, never at 90 degrees because a 90-degree junction causes turbulence and backflow. The inspection chamber is 600 by 600 millimeters located at the property boundary. For maintenance, the public utility is responsible downstream of the inspection chamber. The house owner is responsible upstream. The most common block source is householders flushing rags, wipes, and sanitary items.